Hi guys, my name is Megan Carey and I'm going to be talking about the steps of computed radiography CR and digital radiography DR. Okay, so first and foremost I'm going to talk about computed radiography. What is computed radiography and how does it work, you ask? Computed radiography is a digital replacement of conventional X-ray film radiography and offers enormous advantages for inspection tasks. The use of consumables is virtually eliminated and the time to produce an image is drastically shortened. In computed radiography, when imaging plates are exposed to X-ray or gamma rays, the energy of the incoming radiation is stored in a special phosphor layer. A specialized machine known as a scanner is then used to read out the latent image from the plate by stimulating it with a very finely focused laser beam. When stimulated, the plate emits a blue light with intensity proportional to the amount of radiation received during the exposure. The light is then detected by a highly sensitive analog device known as a photomultiplier and converted to a digital signal using an analog to digital converter, ADC. The generated digital X-ray image can be then viewed on a computer monitor and evaluated. After an image plate is read, it is erased by a high-intensity light source and can immediately be reused. Imaging plates can typically be used up to 1,000 times or more depending on the application. So next I'm going to be talking about digital radiography and the two different types, direct and indirect. In the CR and fill cassette has to be removed from under the patient and fed into a reader to be processed. In digital radiography, the image is produced directly from the image detector and is displayed on the screen. There are two types, indirect and direct. First, we're going to talk about indirect. In indirect, the first layer is a scintillation layer. Most systems use a thin layer of cesium iodine as a scintillator to capture the image, which is coated on the hydrogenated amorphous silicone as an active matrix array. Some systems do use gadolinium oxysulfate as the scintillator layer. The cesium iodine absorbs X-ray photons and releases light photons. These light photons are then absorbed into the photodiodes and the charge storage in the charge storage capitator at each pixel location. The latent image is read out sequentially to a bank of charge-sensitive amplifier, which is TFT switches. The resulting voltage signal is then digested and transferred to the system computer where the DR image is built up. Okay, so that was indirect, and next I'm going to talk about direct and how it differs from indirect. In direct DR, a layer of X-ray photon conductor material is used instead of X-ray scintillator. This directly converts X-ray photon energy into a free electrical charge carriers. The most commonly used photoconductor is amorphous selenium. So in this sequence, X-ray photons are absorbed by the amorphous selenium photoconductors. And next, on electrical charge carriers, negative electrons and positive holes are created in the amorphous selenium. A surface electrode at positive potential attracts and discards all electrons. The positive charges are drawn to the charge storage capitator, forming the latent image. The latent image is then read out sequentially by gating each row of TFT switches. Each TFT corresponds to 1 pixel, in turn to read out the charge pattern and transfer to a bank of charge-sensitive amplifiers. The resulting voltage signal is then digested and transferred to the system computer where the DR image is built up. Okay, so to conclude, those are the steps of computer radiography and digital radiography. Now to summarize, computer radiography, basically the image is formed on a phosphor cassette that is removed, read, and then reset to be reused again. In digital radiography, you have two types of ways. It doesn't use a cassette. You have indirect, which gets the X-ray photons and converts them into light photons by using a scintillator layer, which is normally made up of cesium iodine. And then the light photons are converted into an electrical signal using a photoconductor of amorphous silicone. And then you have the direct DR, which gets the X-ray photons and converts them directly into an electrical signal using a photoconductor layer of amorphous selenium. This one has no scintillators. That's why it just does it directly. Alrighty, well that's the end of my video. I hope you guys learned some steps today and I hope you enjoyed it. Take care.